Here is an explanation for the answer to final exam, question number 66, in Electronics Demystified, 2nd edition. If you have the printed book, please see page 431. We're asked which of the following measures, 5 different possible things we can do, offers the maximum possible amount of protection for sensitive electronic equipment during a thunderstorm. And we're given 5 different options of various sorts. Use a power supply that has a fuse or a circuit breaker, like this. Well, chances are that if a large transient happens to come into this line during a thunderstorm, that fuse will blow, but maybe not before the transformer blows and the diodes blow. In fact, I've had the experience of lightning striking nearby and creating so much of a surge current in the power lines that sparks actually flew from the outlet at the input. Doesn't take a whole lot of rocket science to figure out what happened to this fuse, and somehow, miraculously, these diodes and this transformer survived. Go figure. But that's not a very good way to do it. Not during thunderstorms. B, ensure that the power supply has adequate voltage regulation. Well, that's something that's not even shown in this circuit, but voltage regulation has nothing to do with protecting against lightning hazards during a thunderstorm. C, employ a transient suppressor in the AC utility line. Well, here's an example of how that can be done. Figure 4-13, if you'll go back there. It's a rather primitive way to do it. These capacitors right here, this one and this one, should be small enough not to disturb the AC input that reaches the transformer, but they should be large enough to shunt any sudden spikes in the voltage that may occur. But that's still not a very good way to deal with this kind of a situation during a thunderstorm. Here's another example of transient suppression. We can use thyrectors, devices called thyrectors. Well, yes, that will protect against transients in most situations, but there are those situations where even that technology will not be enough, and the thyrectors are likely to burn out instantly. The choice C, therefore, sounds tempting, but it isn't good enough. D, use the equipment with a 234-volt system rather than a 117-volt system. Well, that isn't going to make any difference. When you get, whether this AC utility line is 234 volts, 117 volts, or whatever, when you get a transient during a severe thunderstorm or a lightning strike very nearby, there's nothing that makes any difference in that respect. You're going to have the same catastrophic surge of current and voltage on your line as a result of something called the electromagnetic pulse, EMP. You may have heard of that in relation to what solar flares can do. Well, a lightning strike nearby can create an electromagnetic field that's powerful enough to set up currents on this AC utility line that can spark all over your house. They can even set your electronic equipment on fire if it's plugged in. And that is what leads to choice E, which is the correct answer to this question. Unplug everything until the storm has passed. That's the maximum protection you can get, and I would further add that when you unplug this plug right here that leads to your equipment, unplug it from any extension cords as well. Don't leave this plug here, this outlet, this plug at the input of your electronic equipment, do not leave it connected to an extension cord, even if you unplug that extension cord at the wall outlet. The electromagnetic pulse from that nearby lightning strike can be sufficient to set up a surge current in that cord that can still destroy not only your electronic equipment, but any electronic transient suppression method like that. So once again, as silly as it may sound, choice E is the answer to this question. Unplug everything until the storm is gone.